Good afternoon. I welcome you all for next lecture series. In this series, we are going to discuss about a medium transmission line. So, I think for the last class, we have discussed about ABCD parameter of short transmission line and necessity of ABCD parameter, and also we can discuss about how can we calculate the parameters A, B, C, D, and why it is called ABCD parameter, and advantages and disadvantages of short transmission line, and all these informations we are discussed in the last session. And today we are going to discuss medium transmission line. So medium transmission line we are considering more than 80 kilometer, less than 250 kilometers. So and it consists of shunt capacitance. I think you all remember in short transmission line we are neglecting the line charging current. Based on this, we are neglecting and we are not using uh, line that is a shunt capacitance. But here in medium transmission line, the line charging current is considering appreciable, and based on this we are using shunt capacitance. So medium transmission line we are going to discuss in two classified, that is three classification, but as per we are going to discuss two type of representation. One is pi representation and nominal T representation, and N condenser method also is available, but we are going to discuss first two methods only. And this first method is the nominal pi representation. So nominal pi representation diagram I will show you. That is, this is the nominal pi representation transmission line diagram. So which consists of two admittance and one impedance. So two admittance are connected near to sending end and receiving end, and these are considers two halves, that is y by 2, and here also y by 2, and there are value of impedance, which is Iz is equal to r plus jx. So it look like pi, that's why that is the two admittance with the impedance. It look like a pi, that's why it is called as the pi representation, that is nominal pi representation. In this diagram we are representing that is sending in voltage Vs, and Is is the sending in current, and through this the current will be flow through this admittance. First admittance is I1, and the second admittance is I3, and I2 is flow through the impedance. And here there is the load is available in the receiving end. Along with this, we know that IR is the receiving end current, and VR is the receiving end voltage. So for this we are going to discuss the transmission line, that is, and I have to show you the pi nominal T diagram. So nominal T diagram is consists of Z by 2 and Z by 2, that is 2 impedance is connected in between the Y parameter, that is admittance is connected. So we can it look like T, that is 2 impedance with the one admittance. It's look like a T, that's why it's called as a nominal T method. And here also we are representing Vs, Is, and IR and VR. So and VR is connected to the load, and I think you are differentiating pi and T, why we are called as a pi method and a T method. So this information we are through the diagram itself we can recognize. And T method, where already I mentioned the value of T method and the pi method. And based on this, we are calculating and voltage regulation and efficiency. Along with this, we are discussing the um, vector diagram for the lagging and the leading power factors. Also, we are discussing the ABCD parameters and what is the advantage and disadvantages, where we have to use all those things we are discussed in next section, and how to calculate the efficiency and the regulation also through this equations we have to discuss in the next section. Thank you all.